Coulomb's torsion balance. Charles Augustin de Coulomb measured the magnitudes of the electric forces between charged objects using the torsion balance which he invented. Coulomb's torsion balance is an instrument that enables us to verify experimentally the quantitative law of interaction between electrical charges. Coulomb's torsion balance consists of a cylindrical or square glass case closed by a lid. A glass tube emerges from the lid. The tube is closed with a piece of metal called torsion head. A torsion fiber is suspended from the torsion head. This fiber holds a horizontal needle made of lac with a small brass disc at one end and a sphere of elder pith at the other. The height of the needle is adjusted by a knob which is turned to wind the suspending thread on a horizontal axis. A scale that is circumscribed on the glass case is used to measure the torsion produced in the fiber. Let us see how Charles Augustin de Coulomb deduced the famous Coulomb's law. In order to study the intensity of the interaction force between two charged bodies, the brass disc was made to touch a small metal sphere, which was at the end of a glass rod suspended from a hole in the glass lid of the balance. Coulomb observed that the thread suspended from the needle did not move as both the disc and the sphere are without charge. The sphere suspended from the lid of the balance was removed and charged. He placed the sphere back into the balance. The sphere and the brass disc repelled each other as the disc attained the same charge as the sphere. As a result, the needle started oscillating. The torsion angle of the thread was measured using the degree scale marked on the glass case. In order to ascertain the ratio between the interaction force and the electrical charge on the bodies, Coulomb removed the sphere suspended from the glass rod and placed in contact with another sphere of the same size. As a result, the charge of the sphere was reduced to half. The sphere was placed back into the balance. It was observed that the electric repulsion between the charged bodies was less. He then calculated the ratio between the interaction force and the electrical charge on the bodies by measuring the angle of torsion. Coulomb found that the force between 2-point charges was directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. Mathematically, if two bodies carrying charges q1 and q2 are separated by a distance r, then the force is given by F is directly proportional to q1 q2. F is directly proportional to 1 by r square. F is directly proportional to q1 q2 by r square. F is equal to k into q1 q2 by r square. K is the proportionality constant called the electrostatic force constant. The value of K is equal to 1 by 4 pi epsilon naught, that is equal to 9 into 10 to the power 9. The relation F is equal to K into q1 q2 by r square is known as Coulomb's law.